Okay, so to find our common denominator for this problem, we're first going to do the prime factorization of each denominator. So remember, there's multiple ways to split up some prime factorizations, but you'll always end up at the same place. Okay, so 24 is equal to 2 times 2 times 2 times 3. And then I'll also do the prime factorization for 27. Okay, so again, I could do an exponent, but in this case, I think it may be better to leave it written out. Okay, so my first term is 5 over 24, which I'll rewrite as 5 over, and again, instead of 24, I'll write its prime factorization. And then for 2 27ths, again, leave some space over here. And then instead of 27, I'll write its prime factorization 3 times 3 times 3. Okay, so we basically need to make the two denominators match. Okay, but we can't take anything away. We can only add more until they match. Right? So for example, this left denominator has 2 times 2 times 2, while the right denominator doesn't have a single 2 in it. So in order to get the 2's that the right side needs, I'm going to have to multiply by 2 times 2 times 2 because it doesn't have any at all. Okay, and of course, to keep it balanced, I would have to multiply the top by the same thing. Okay, so now what does the right side have that the left side doesn't? So we've got all the 2's, but the right side has 3 times 3 times 3. The left side only has a single 3, so it's missing 2 of them. Okay, so in addition to the single 3 it already has, it needs 2 additional 3's. Okay, and then again, to keep things balanced, if I multiply the denominator by that, you have to multiply the top by that as well. Okay, so now both denominators should match. I have 3 2's and 3 3's, 3 2's and 3 3's. Okay, so both match, so now we can simplify each part separately. So over here, 5 times 3 is 15 times 3 is 45. Okay, and what is that denominator? 2 times 2 times 2 is 8, and then 8 times 27 would be 216. Okay, and then over here, our numerator, 2 times 2 is 4, times 2 is 8, times 2 is 16. Our denominator, again, should match, so I don't need to calculate it again. The whole point of this was to make the common denominator. Okay, so that's how we can use prime factorization to easily find a common denominator to aid in the addition or subtraction of rational numbers. So I'm going to apply the same principle as adding and subtracting rational numbers to adding and subtracting rational functions. Okay, so I see that these two rational functions I'm trying to add do not have the same denominator. Okay, so this first time I'll write it out. As you get more practice, this probably won't be necessary. Okay, so the numerator is 2x, that's simple. Denominator is 5ab to the third power. And I know that b to the third power really means b times b times b. Okay, and then leave some space, and then I'll do the second rational function. Numerator is 4y. Denominator 3 times a squared, so 3a times a, and then times b squared. Okay, so any excluded values. So again, here's where it's really important to see that you need to list your variables. So if a is 0, this whole denominator becomes 0, so a can't be 0. If b is 0, this whole denominator becomes 0. Okay, if a is 0, this whole denominator becomes 0, but it was already excluded value, and same thing with b. Remember, x and y, it's okay if they're 0. We don't care if the numerator equals 0 in terms of excluded values, only the denominator. Okay, so now we need to match the denominators by giving them what they're missing. Okay, so I'll start on the left. Okay, so what does the right denominator have that the left one doesn't? The right denominator has a 3, and the left denominator doesn't. Okay, so I know I'm going to need to multiply by 3 over 3. The right denominator has a times a. The left denominator only has a single a. So I need an extra a as well. Okay, the right denominator only has 2 b's. The left denominator has more than enough, right? It's got the 2 b's it needs and then some, so we do not multiply by any extra b's. Let's repeat the process for this one. Okay, so what does the right denominator need to match the left? Okay, so it's got the 3, but it doesn't have a 5 yet. Okay, so multiply top and bottom by 5. Okay, so it's got 2 a's. The left denominator has 3 b's. The right denominator only has 2, so we need 1 additional b. Okay, so now we can simplify. So over here we got 2x times 3a is 6ax. Denominator we can now combine. 3 times 5 is 15. And we got a squared b cubed. And then this one we got 4y times 5b is 20by. And then over here we have 3 times, again, it should match here. I don't need to calculate it again. Okay, then finally just add the 2 functions now that they have the same denominator. Okay, so remember, you should not try to simplify anything here because, like, even though the 6 and the 15 have, say, 3 as a common factor, the 20 doesn't. So we don't want to split it up. We want to leave it as one single function. Okay, so I'll do letter C as well. Okay, so I'm going to start the same way as usual by factoring. So this first rational function can't be factored because it's x's to the first power. Okay, leave some space. This second function's denominator can be factored. Okay, I'm just going to go back and put parentheses here. Okay, so next step, I want to check for excluded values before I do anything else. So over here, I see that x cannot be -2. And over here, again, x cannot be -2, but also x cannot be +2. Okay, so now how do I make the denominators match? Okay, so this right denominator already has everything it needs. It only needs an x plus 2, and it's already got that. But the other way, this left denominator has the x plus 2 it needs, but it doesn't have the x minus 2. So we're going to multiply by x minus 2 over x minus 2 to make the denominators match. Okay, so the numerator, I'll go ahead and distribute out. So 3x times x would be 3x squared. 3x times -2 would be -6x. Okay, the denominator I'll leave factored though. The reason is the numerators can combine, but the denominators don't. Okay, so 3x squared has nothing to combine with in the numerators. But -6x plus 12x would be plus 6x. And again, keep the denominators. Okay, so this can be factored. The numerator has a greatest common factor of 3, actually 3x. Okay, so 3x squared with the 3x taken out, there's just an x left over. And then 6x with a 3x taken out, that's a plus 2. Keep the denominator the same. Okay, so now we can see that the numerator and denominator both have a common factor of x plus 2. Okay, it's very important to make sure that the x plus 2 is actually multiplying the rest of the numerator, right? Because otherwise, like if there were a plus sign in between the 3x and the x plus 2, then the x plus 2 would no longer be multiplying. It would just be adding, so it wouldn't be a factor. But in this case, we can reduce. Okay, so that leaves us with 3x over x minus 2. Okay, for this problem, I would start by factoring, but there's actually nothing to factor. Everything is to the first power already. So I can do my excluded values. A cannot be -1, and a can also not be +1. Okay, so let's make the denominators match. Okay, so I'm going to put parentheses around both denominators. Okay, so starting with the left denominator, it needs an a minus 1. It doesn't have it. So we're going to need to multiply to create one for it. And we'll do the same thing to the numerator to balance it out. Okay, so now the right denominator, it has the a minus 1. It also needs an a plus 1, which it doesn't have. So we're going to have to create an a plus 1 to multiply it. Okay, so I'm going to do this next part without distributing yet. Okay, so in this left numerator, I have a times a minus 1. Okay, then I have a minus 1. And then this -1 multiplies the a plus 1. Okay, and then the denominator will be a plus 1, a minus 1. Okay, so remember there's no reason to reduce right now because if we cancel out, we're just going to get back to where we started. Actually, there isn't a common factor yet anyways. Okay, so the very common mistake that happens with subtraction problems is not distributing this minus sign. Because this, you're not just subtracting the first thing you see, you're subtracting the whole second term, no matter how long the numerator goes. In this case, you're subtracting not only 1 times a, but also 1 times 1. Okay, so over here we have a squared minus a. Then from here we have -1 times a is minus another a. Then we have -1 times +1 is a minus 1. Okay, and again, the denominator is the same. Okay, let's combine the like terms in the top. We have a squared minus -a minus another a is now minus 2a, and then minus 1 all over a plus 1, a minus 1. Okay, numerator is not factorable, so this is as fully simplified as we can get.